Okay, we continue the Cartesian vector. This is part 3. So find the coordinate and the magnitude of this. So AB. So for the AB, I need to say B minus A. B is 7, 2, and A is 1 and 3. So 7 minus 1 is going to be 6. 2 minus 3 is negative 1. So that's going to be my vector. The magnitude of the AB going to be x component power 2 plus the y component power 2 equal to 37. So that's going to be the magnitude. So next question. Write the 200 Newton at 20 to the Cartesian form. So I just need to draw that first. So at 20 degree, I'm assuming that 20 degree gonna be my x, like the angle that it makes with x-axis. So if this is 200, I know the x component according to this trigonometry ratio. So let's say this is x component, this is y component. The sine of 20 is going to be opposite over hypotenuse, and the cosine of the 20 going to be adjacent over hypotenuse. Sorry, cosine of the 20 is adjacent over hypotenuse. So here I can solve for x. X gonna be 200 cosine of 20, and the y gonna be 200 sine of 20. So if I want to write this one in x and y components, let's say I say v, vector v, the x component gonna be 200 cosine 20, and the y component gonna be 200 sine of 20. You put that in a calculator, you will get 187.9 and 68.4. That would be the x and y component of this vector. So the next question is that a ship's course is that travel at a 23 kilometer per hour relative to the water on the heading of 40. A current of the 8 kilometer per hour is flowing from the bearing of 160. Write the Cartesian vector for each, determine the velocity of the ship. I know the velocity of the ship. The current is pushing the ship, so means the velocity of the ship plus the current is gonna be whatever I will see from the shore, right? They help each other. So if I want to do for the ships first, it's gonna say heading of 40 degree. Yeah. Heading of the 40 degree. So we're seeing that this is the bearing of the 40, right? Bearing means you start from the north, and it is 23. So the course ship travel 23 kilometer per hour. I want to write an x and y component of that. So I know that if this is 40, this will be 60, right? So the x component of the ship is gonna be what again? So for x component and the y component, for x component is the cosine of that, right? So it's gonna be 40 cosine of the 60 degree, and for y component of the ship is gonna be what? Opposite, which is 40 sine of 60. So x and y components, I now have it. So I call it S for the ship. So x component is 40 cosine 60, and the y component gonna be 40 sine of the 60. Now for the other one is the bearing of 160 is from the bearing of the 160. I know 160 is, if this is, you start at north, 160 would be somewhere here, like that. If this is 160, what would be this? Because this is 180. It's gonna be 20. So it's not gonna be in this direction. So it's from that bearing. Means the direction is there. Means I need to continue that there. If I wanna do that, and I know if this is 20, this will be 20, and this will be what? It's going to be 70 because total is going to be 90 degrees. So, and this is going to be 8 kilometers per hour. So now x and y component again, I want to see x and y component. For x component of the water or current is going to be what? 70 cosine of, 8, the magnitude of that. Cosine of the 70 degree. Since the x component is negative, I put negative here. And the y of the current is going to be 8 sine of 70. So C, the vector C, current, the x component is negative 8 cosine of 70. And the y component is 8 sine 70. Now I want to see the result and what I see from the shore. So of course you have to add these two vectors. This is simple. So the first one is 40 cosine 60, 40 sine 60 plus negative 8 cosine 70, 8 sine 70. You know how to add two vectors. Just adding the x component and we add the y component together. 40 sine 60 plus 8 sine 70. So if I use a calculator to calculate this, it would be 12.048, and here is going to be 25.137. I need to find the magnitude of this vector, the resultant. So what I do, let's say this is the resultant, vector resultant. So R is going to be square root of 12.048 power 2 plus 25.137 power 2. And then I put in a calculator, it's going to be 27.875. So again, I know the x component of my resultant going to be positive and 12.048, and the y component going to be 25.137. So this is going to be R, right? I need to find this theta. This theta is going to be, I can use a tan theta is 25.137 divided by 12.048. Also theta gonna be tan inverse of this. Now using calculator is gonna be 25.6. So R, then I say R is the vector R is equal to what? 27.875. It's going to be east. 25.6 north. That would be the direction, and this is the magnitude. So any vector has a direction and a magnitude. So I want you to go to the page 367 and do all of these questions for me.